Hi, welcome to the next video session or video lecture in the big data analysis. So we have already started with the second module. In the previous session we have seen the various big data technologies which is used in the market, depending upon the features we had classified based on the storage part, analysis part, then the mining part, and the visualization. Based on those four features we have seen lot of technologies which is used in the market. So now one by one we will be looking into the insight of the various important definitions, or we can say the important areas in the big data technologies in the industry. Now starting with the overview of the Hadoop. I will be just looking just overview, just will define what is that particular Hadoop, because later on modules will be going into detail about this Hadoop. Now what is this Hadoop? Now Hadoop is nothing but let me select the highlighter here. This is text. Okay, this is the highlighter. Hadoop. So Hadoop is an open source technology. So it is an open source technology generally which is used built in a distributed environment, so that we can store the huge amount of the data and process the big data. So when you come to the developers of the Hadoop, there are two important persons. One is called as the Doug Cutting and the Mike Kefferlia. Now these are the Kefferlia as well as the Cutting are the two important persons who came up with the this particular platform, or the Hadoop technology, or we can call them as the creator of the technology. Basically they were building a product called as Nuts. So their main goal was to build a web index. They built a large web index. So to do this, now they referred the white papers from the Google, where the Google were using the Google file system as well as the MapReduce concept in order to in their search engines, etc. Now they took a lot of concept from that in order to solve the nuts of the problem what they were defined for the nuts, but they came up with the two important concept, and they called it as an Hadoop project. When we look into the name of the Hadoop, is there any abbreviations for a Hadoop? No, we don't have any such abbreviation for an Hadoop. Actually Dog Cutting's son, now he was very fond of a very small elephant. So, and that particular toy, that means the elephant, not a big elephant, okay, it is just toy. He was playing with the toy. Always he is very fond of a very small elephant toy, and that toy, name of that particular toy was Hadoop. So he gave this entire project itself as called as an Hadoop. Now when you look into the important features of the Hadoop, why today Hadoop is so important, why it is so much used in the industry. So if you look into this, these are some of the important characteristics. Anyhow, in detail we'll be looking when we walk through the entire Hadoop in the next course. The first one is the flexibility in data processing. It's very good in flexibility. Scalability, the Hadoop is scale out, or we have horizontal scaling in Hadoop. Fault tolerance, we don't have a single point of failure here, and very fast data processing. We have a separate component called as MapReduce, which is used for data processing, because the data is stored in distributed environment here. And Hadoop has got a very big ecosystem. We'll be discussing about the ecosystem also. Cost effectiveness, it is open source free, so that is why these are some of the important characteristics or features of the Hadoop. Coming to the components of the Hadoop. Now right now we will just say that Hadoop has two important components. The first component is called as the Hadoop distributed file system, or it is called as Hdfs. Hdfs. So these are the common terms from right now onwards we will be using whenever we are talking of the Hadoop. The first one is Hdfs, Hadoop distributed file system. What is this Hadoop distributed file system? In a very nutshell, if I want to define, say that it is a file system wherein which you are going to store the data in a distributed environment. The huge amount of the data, or if you take let us take a single file, if you just take a single file, you want to store single file in Hdfs. Now when you want to store a single file in an HDFS, now that particular single file is divided into cluster and it is stored in a distributed environment. So it goes into various computers and it stores. How it is actually working, how the HDFS works, what is its architecture, we'll discuss it later. So it has got one important component is HDFS, distributed file system. The second important component is called as the MapReduce. Now this is the one which is used for processing the data. Now the storing part of the data, it is in Hadoop, the data is stored in HDFS, and MapReduce is one through which you are going to process the data. So you are going to collect some results, you want to do certain action on this data, then we are going to use the MapReduce. So these are the two important. Right now we can think two important. Later we'll be discussing some another important component. Basically it has three important components in Hadoop right now. With respect to the older version of Hadoop, we can say HDFS is one important component which stores the data. MapReduce is another important component which is used for processing their particular data. So next, now we will be discussing a very important thing, that is why Hadoop. What is the difference between this Hadoop and our traditional RDBMS, right? So we are using till now RDBMS, MySQL we are using. Now why suddenly so we are leaving this RDBMS and going into the entirely new technology of the Hadoop? Basically the three important things. One is the processing speed. So as the processing speed of the systems increase, GPUs have been increased. Now it helped various technologies to come up, so that when the processing speed increases, now we have huge and new technologies which really helps us to support or to store the data and process that particular data. The second important thing is the storage capacity. So nowadays the storage is cheaper compared to the previous days, or you can say just 1 decade back. If you go back, the storage, you have to pay a huge amount for the storage. Now the storage has become very cheap for us, so it helps us a lot. The third one is the dealing with unstructured data, because we know that 80% of the data, whatever we are going to gather, it is in unstructured form, it is not structured form. So we need some technologies, we need such that we can deal with the unstructured data for us. Since the technologies came up, now it becomes easy for us to deal with this. So these things, now we will go into the one by one difference between the traditional RDBMS what we are having and our Hadoop environment, or we can say the Hadoop. When we are talking about big data, we go for Hadoop. Why we are going for Hadoop instead of traditional RDBMS? There is one by one differences we will find it. Now of course we have given a material already regarding to the differences, because this is an important question with respect to the examination. What is the difference between the older approach and the newer approach? You can refer this transcript also here. The same what you can say the differences. Now we have broken down into the features. Based on the features, we are going to look the differences. Now we will first start with the first feature, that is the data volume. So we have defined this volume as one of the important characteristics of the big data. 1V. We have said that 3 V's are very important. Now in that 3V, the first V is the volume. So volume is huge amount of the data. Now when you go to your RDBMS, now RDBMS is very good when working with low amount of the data. That means when your data is very small. So when your data is in terms of gigabytes, good, RDBMS is perfect, it is very fast, you can go with that. But as your data increases, as the data increases, when you are talking of terabytes of data, when you are talking of petabytes of the data, then the RDBMS is not a good answer for us. So we are going for the Hadoop, because Hadoop works better than RDBMS with respect to the huge data. The efficiency becomes very good when we are going with the Hadoop. So the first character is the data volume. So next we'll look into the second important character, architecture. Now what makes these two difference? Now what is that architecture what we are using in RDBMS, and what is the architecture here we are going to use? As we have seen, we have defined that now Hadoop two important components. So we have got Hdfs and we have got MapReduce. So through Hdfs we are storing the data, and MapReduce we are going to process the data. That is what right now we have said about yarn. We will discuss it later. So this is how we have two important components. Now when you go to your traditional RDBMS, now you know that in MySQL or the Oracle database what you have used, it is a structured database, right? So where we talk of primary key, where we talk of data integrity, where we talk of normalization of the data. Now all those things does not play here, because all those things comes into the picture with the property what we say that almost all RDBMS, traditional RDBMS possesses this ACID property, that is atomicity, consistency, isolation and durability. So these things we are going to talk more in RDBMS, whereas when you come to the Hdfs or when you come to the Hadoop, we don't talk of all those things. So with respect to the architecture wise, there is difference, because when you take your RDBMS, when you are talking of atomicity or acid property or various other things, so we talk of structured data and semi-structured data. But what about the unstructured data? As we know that 80% of the data we have to manage is unstructured data. So again, there is a pitfall with respect to the traditional RDBMS. The third feature is the throughput. Now what do you mean by throughput? So I think what is a throughput definition, or throughput, or how do you calculate throughput? I think you might have studied in your operating system. Now anyhow, when we are going to look at the throughput, we can define throughput is nothing but the total amount of volume or the data we are going to process at a particular period of time. So in one particular period of time, how much amount of volumes or data you are going to process, it is termed as a throughput. So the more and more volume of data you process, your output is maximum. So now RDBMS, now it has got a very less throughput compared to our Hadoop. Now RDBMS fails here to achieve a higher throughput, whereas Hadoop, now here we can process huge amount of the data in a given period of time. So the next feature through which we discuss the differences is the data variety, unstructured. As we know that data variety means we are talking of unstructured data. So we have got various different types of the data which we are supposed to manage. Like say it can be a text file, you have got PDF file, you might be having images, videos, likes, tweets, posts, etc. So we have so much of unstructured data. Now Hadoop is very good because it has the ability to process and store any data, any type of data you say. It need not be only text or Excel file or a PDF file. You give any type of data, you can store it in Hadoop. You can process that. So that is an added advantage. But when you're talking of traditional RDBMS, you can store only structured data, to some extent semi-structured data also, but you cannot deal with the unstructured data in your RDBMS. Whereas in Hadoop, since data variety is very important feature of a big data and Hadoop supports that, so it is we can go with the Hadoop compared to our RDBMS. Next feature we discuss here is the latency or response time. So response time or the latency time, how fast. So now when say for example, now when you're talking of an Hadoop and you store huge amount of data in the Hadoop, how much time you require to access one particular record? Now you can just think about that. Your record is not stored in one place, it is stored in Hdfs, that means a distributed environment in various places. If you want to access one particular record, obviously it will take time for us, right? But if you are storing it in traditional RDBMS packages to extract one particular record, it is very simple and it is very fast. You just write one simple SQL query, select star from so and so, you got your record. So when we are talking of latency time, that is retrieving information from your data set, is very fast in RDBMS, whereas it is very slow in Hadoop. So in this feature, when you are talking about this particular feature, our RDBMS goes on top compared to the Hadoop, because in Hadoop the retrieval rate is very less. So actually Hadoop uses the batch processing system, whereas the RDBMS uses the online transaction. It is again another feature which will be discussing. So next feature is scalability. So scalability means when you are talking about the RDBMS packages, now here we use one term called as scaling up, so which is nothing but vertical scalability. So your RDBMS, we have got the scaling up feature, the vertical scalability. So that means, so if you are going to store a database of one organization in one particular server, now suddenly after few months the data has increased, you cannot incorporate in that particular server. Now what is the solution for us? Again, you have to procure a new server, you have to store the data, so and all the additional machines or additional computers, everything is required. You need more and more servers here if your data keeps on increasing. Whereas when you're talking of Hadoop, now it provides the horizontal scalability, that means scaling out. So in RDBMS we have got vertical scalability, whereas this is horizontal scalability. Now in horizontal scalability you don't need more and more servers, right? So we don't need all those things. As your data increases, just one cluster is enough for us. Just you add just one node, store some data in that particular node. Again tomorrow, again the data increases. If you are not able to store in this node, keep on adding another node. So you need not maintain a huge amount of server here. So in scalability wise, again Hadoop has got a very advantage approach. When you're talking about the scaling up, you will be having a single point of failure. That means if that server is having some problem, your entire data is gone. Whereas in Hadoop you don't have single point of failure. So the next feature here is the data processing. So how the data is processed in Hadoop and traditional RDBMS. Now in Hadoop supports online analytical processing. Now this is generally used in data mining technique. So where we see that very complicated queries or aggregations can be used. So the data processing speed depends upon the amount of data, which can take several hours. So here what happens, the data for processing, it takes several hours for us in Hadoop, because you are storing huge amount of data, right? Now whereas when you are talking of RDBMS, now it supports OLTP, that is online transaction processing. So it is very fast. The query processing in RDBMS is fast compared to our Hadoop. So especially when you are working with an application which is related to the transaction processing, where you need the process to be done, the results analysis to be done very fast, in very seconds, in few seconds, at that time Hadoop is not a good answer. We have to go for relational RDBMS, because online transaction processing you are doing, so which is very fast compared to our Hdfs. And the next characteristic, of course, is the cost. Now when you are talking about the cost, now you can say that RDBMS, if you are going to use RDBMS, it is a licensed software. You have to purchase that particular software, whereas Hadoop is an open source. So later the video session we will be discussing what is this open source, what are the important things comes under our open source softwares, right? So cost wise, again Hadoop is on the top, RDBMS goes down. So now these are the various features. Based on the features, we have tried to differentiate the older approach, that is RDBMS, and the latest big data approach, that is our Hadoop. The same thing has been given in one particular table, so you can just look into the transcript later. Okay, so next we'll go to the another important concept which is there in industry, which is called as the data discovery. Now usually the organizations or the industry was working on one technique called as the business intelligence. So it was a very hot, or we can say the business intelligence, wherein which you are taking the data, you are analyzing that particular data. Now the traditionally what is happening, right? So they are moving from business intelligence to data discovery. Now let us see what is the definition of this data discovery. So we can see here, now data discovery means it is nothing but you are going to collecting of the data, analyzing of the data from various sources, and you are going to see what is the insight from the hidden patterns. So from the previous data or the data source, you collect, analyze, and try to get some hidden patterns and trend. so which we call it as the data discovery. So it is a new way of business intelligence what we are right now. So we have crossed that business intelligence and we are moving towards another step which is called as the data discovery. Now the data discovery again, and it has lot of steps are involved, how we are going to collect the data, how we are going to analyze the data. Now since this data discovery itself has become a very important thing, now there are various organizations itself who are only meant for discovery, who are only meant for collecting the data. Say for example, the best few companies are like say Tabula Software and Click Technologies International. Now, these are all the companies. Apart from this, we have so many other companies who are best world recognized only in the data discovery. Now what is their role? What this company does? They are not going to design any software for us, but what they do, they collect the data. Now collecting the data, cleaning the data, combining the data is done by them. So if you need a data as an organization, now it is very difficult for us to work or collect the data, but there are specialist people, there are data scientists are available. Okay, so what their job is just collect the data. They have their own methodology. There are certain steps there are tools are available for the data discovery also. They use those tools, they use those steps, they collect the data, clean the data, combine it, and even to some extent even they do the analysis of that data also and give us. So we see that the organization from the business intelligence, they are moving into the data discovery. This is another concept. Okay, so now we'll come to another important term called as predictive analytics. Now already we have defined what is a predictive analytics, I think in our first video lecture series when we discussed different types of analytics. Now gradually now what is happening is that the industries, now they are moving from a reactive position, that is the business intelligence, towards a learning positions. From the business intelligence, they are moving to predictive analytics. They don't want to run the organization by just using the intelligence, but they want to predict what is going to happen in future, right? So can I sustain our organization in the future? So they want to predict what is going to happen. Now if you are going to define the predictive analysis, we can define it as it is nothing but use of the data, and we use some statistical algorithm and machine learning techniques. By using the statistical algorithm, machine learning techniques, now you look into the futures. So you try to identify the likelihood of future outcome based on the previous data or the historical data. So the major goal of this predictive analytics is that you are going to tell today itself what is going to happen. You are going to predict how your company is going, how your company will be in the next year, what will be your sales of your company, right? So like this, there are a lot of applications of this particular predictive analytics, so wherein which you are going to forecast whatever is going to happen in future based on the past and the current data whatever you are having. Okay, so some of the applications we can see here is that in the retail industry. So in the retail industry, now often we use the predictive modeling to forecast inventory requirement. Now how will be the inventory requirement, how we are going to look into the shipping schedules, the storage layouts, so that maximize the sales. So because if the one side for your organization you have a sales and the other side you have got the inventory. Now retailers, you are going to look into the forecast your inventory based on your sales, right? So you can use the predictive analytics here. Even in the airlines, they use frequently they use the predictive analytics to see that how the tickets has to be booked well in advance, how much concession has to be given based on the previous history of the travelers. Hospitality industries, like say it can be hotel or a restaurant, they are also using this technology to forecast the number of guests or the tourists, whether they are going to increase or decrease, now how they are supposed to deal with the situations. And similarly, like say companies like Netflix, Amazon, they are using recommendation engine. This is again another thing. They are going to predict they are going to predict by using recommendation engines for the customers based on the past purchases. Now previously how much you have purchased, now what items you have purchased, what was your range in which you are purchasing. Based on that they will predict and they will recommend which product is suitable for this particular customer. I think this is the best example which you might have seen, like when you go for an Amazon or a Flipkart or whatever the online sites are there for purchasing your online products. So now once you select one particular product on today, so based on what type of product you have purchased, what was your range, based on that, based on the liking down, you will be seeing that there are certain recommendations, right? Now they will do the analysis and they will recommend for a particular customer what is its range, in which range what product he might be looking forward, so they will try to give it. So even risk engines, so like say the financial organization, they look into the credit risk, they calculate the credit risk before sanctioning, looking into the market and all, portfolio risk. Now there are so many organizations which use the risk engine for the predictive analysis. Innovative engines, say for example you want to innovate a new product, right? So you are going for an innovation of a new product, you are going for drug discovery, like say for example now how you are going to come up with a new drug. Now how the right now you can see the day and night how the researchers, how the IT team and the medical team and the scientists all are working to come up with a new vaccine or a drug for to fight with the corona, right? That particular the problem what we are facing. So innovative, they are going to come up with a new thing. So to do that, what they need, so they look into the past data, the current data, and they try to predict how you can come up with a innovative product. Or it can be in the fashion trends, how they come up with the innovative fashion trends with respect to the technology or the age of the customers, right? Similarly, the customer insight engine, this is another important thing. So say each organization tries to study the sentiment of the customers, they try to study the behavior of the customers or emotions of the customer, and give some lifetime offers, they give some discounts to the customer. So they don't generally give discounts to each and every person, they go with the analysis nowadays. So they try to do the analysis, they try to predict that okay, if I give the discount to such a type of customers, they will be my lifelong customers, so that it increases the product, it increases the revenue of the organization, it increases the name of the organization, etc. So you can use it in the customer insight. Similarly, optimization engines, so even we can use the predictive analysis for optimization. So you know what you mean by optimization, just to maximize the output by reducing your cost, minimizing the resources and maximizing the output. So you can predict, you can use the predictive analysis how actually we can maximize the profit and how to reduce the operational cost, where all you can reduce the cost so that you can increase your actual profit. So for optimization also we can try to use the predictive analysis. So this is about what is the predictive analysis and various applications of the predictive analysis. So in this lecture where we are going to end this particular session. So you have seen mainly we have focused on the difference between the traditional approach of RDBMS and Hadoop, and what is the data discovery and what is the predictive analysis. So if you have got any doubts or queries, as usual you can drop in comment on the classroom, or I think recently we created WhatsApp, I have created WhatsApp group also. Still some students are supposed to log into that particular group, there also you can just send a message. So this is about today's session. So in the tomorrow's session, now we will go into some other concepts, like we'll be discussing what is a cloud technology, how the big data and cloud is going to work, what is business intelligence, and various other concepts we'll be discussing in the tomorrow's session. Thank you for listening to